Okay, today we're graphing logarithms. So remember, logarithms always have a common base of 10 if it's not written. Log of x. Right? And we still need to know how to write that in exponential form. So instead of f of x, I'm going to write it as y equals log of x. Since it has a common base of 10, so 10 raised to the y equals x is how we would graph logs. So first off, graphing exponentials, remember there's a horizontal asymptote unless it's moved up or down. At y equals 0. And then we plug in -2, -1, 0, 1, and 2. Remember, plugging anything raised to the 0 is 1, 10, 100, 10 times 10. And then negative exponents give you those fractions. So 1 over 10, 1 over 100. 0.1, 0.01. I think that's right. And then those are the points we're graphing. So 0, 1, we're just sketching this. 1, 10, 0.1, 0.10, something like that. And then this is the inverse of that. So inverse, or how you cancel out an operation, like the inverse of addition and subtraction, inverse of subtraction is addition. That means you're switching your x and y's. That's what inverse means. You can switch your x and y's. So that's why we had to graph this one first so that we can switch our x and y's. 2, 1, 0, and 1, and 2. So now I'm doing 0.1, -2. I'm sorry, 0.01. 0.1, -1, 1, 0, 10, 1, 100, 2, slowly going up, very, very slowly. Like at 100, it's 2. So don't be drastic there. And my asymptote also flips. So now I have an asymptote of x equals 0. So in the logarithm, you have a vertical asymptote. In exponential, you have a horizontal asymptote. In the old calculators, you couldn't graph anything besides base 10 on your calculator, but we can. But this is just so you know how the graph looks. You do want to graph exponentially first so that you know the points for logarithms. So let's do a few. You know, just pause the video. Okay, so we have log base 2 of x. I know it says f of x, we're just going to say equals y. So what this is saying is f of x equals, the inverse of that equals 2x. So the inverse of log base 2 of x equals y is 2x. And that's because if you write it in exponential, it'd be 2 to the y equals x, which is why I had the y there. So you can see the y and the x are in different spots. So if you do exponentially, 2 squared is 4, 2, 1, 1/2, 1/4. Since we're graphing, I don't like leaving it as a fraction. Can't graph a fraction, you graph a decimal. And then, so that's the inverse of this log. So then you switch your x and y's. So 0.25, 0.5, 1, 2, 4. Unless this graph is moved left or right now, it won't have your vertical asymptote will stay at 0. So unless, I'll show you the transformation equation in a minute. So unless the graph is moved left or right, you don't have, your asymptote will be at x equals 0. With exponential, it's up or down. With logs, it's left or right. Just to clarify. Okay, so these are the points we're graphing. 1, 0, 0.5, negative 1, 0.25, negative 2, and it goes down. 2, 1, 4, 2, 3, 2 cubed is 8, so 8, 3. It goes on that way. Okay, so when you do domain is left to right. So starting the left, the first thing you get to is your asymptote at 0. You'd never cross that, but it'll start right after that. So like 0.25, 0.125, stuff like that. And then it goes on forever to the right. The range is going down forever and up forever. Very, very slowly, but this is going up forever. Look, this is switched. Now I'm asking what x is doing when y is going to positive infinity. So when y is going to positive infinity, when this graph is going up, my x's are headed to the right. That's what this is saying. When your graph goes up, my x is headed to the right. When my graph is going down, my graph is heading towards my exit value of 0. And then x-intercept 1, 0. All right, these are a little trickier, but you can still graph it in your calculator. Log base 2 of x. I graphed it. When you look at the table, you get a lot of undefined because that's where your asymptote is. And remember, you can do menu trace, graph trace, and put in, just type in 0.25, and it'll give you negative 2. But you'll have to know those points. So it's a little easier just to know your exponentials and then do the inverse of it. Right, let's do another one. So log base 1/3 of x. Well, the inverse of that is 1/3 to the x. And with exponential equations, we're always plugging in negative 2, negative 1, 0, 1, and 2. So this is 1/3, this is 1/9. This is 1, any number raised to 0 is 1. Negative 1 means I would flip my fraction, and then 9. So then the original, or the inverse of that, 9, 3, 1, 1/3, 1/9. Negative 2, negative 1, 0, 1, 2. Asymptote still at 0 because we haven't moved left or right yet. 9, negative 2, 3, negative 1, 1, 0, 1/3, 1, 1/9, 2, and it's going up. So a base is a fraction reflected it down. Changes it from a growth kind of to the decay. And if you turn your screen sideways, you can see 1/3 to the x. That's what we graphed this way. You can see 2 to the x. That's what we graphed that way. Domain, left to right. First thing you get to is your asymptote at 0 to infinity, going right forever, going down forever, going up forever. So just like exponentials always have a domain that's all real numbers, range always has a logs always have a range that's all real numbers. Struggling to wake up this morning. Sorry, guys. Okay. As y goes to positive infinity, as your graph goes up, what's your x doing? As my graph goes up, my x is getting closer and closer to 0. As my graph goes down, so these numbers, my y values go down this way. My numbers are getting bigger and bigger and bigger. Positive infinity. As my graph goes down, my x values are getting bigger and going to infinity. It's really weird when you flip those around. X-intercept 1, 0. Y asymptote x equals 0. I wasn't moved left to right yet. All right, since logarithms are brand new to you and the graphs are brand new and you have to do it as an inverse to graph, we are only going to move these graphs left and right. We're not going to worry about vertical stretch, vertical compression, or reflection. We are only going to move these graphs left to right. So you're going to have log of a number, log base b of a number, and then the h inside your log is going to move it left to right, and then the outside number is still going to move it up or down. So inside your function is left and right, outside is up and down. And that's all I'm going to do. I'm not going to make it any trickier than that. Even though you have a graphing calculator, so you can always just graph in the calculator. So the inverse of this one is, just thinking about the parent function, is 4 to the x. And then the transformation inside my parentheses is going to move it negative to the right 1. So I'm going to take my x values. So I'm going to do this in a few steps. F of x is 4x. The inverse of the parent function is 4x. So if I plugged in -2, -1, 0, 1, and 2, I'd get 16, 4, 1, 1/4, 1/16. Right? So then I'll inverse those. I'll flip those around, which gives me the log. Ah, I flipped them around. Sorry. And then I still have to move it right 1. So right affects the x's. So I'm going to, if you're here and I go right 1, I add 1 to all my x's. So here's what I'm actually graphing. 1.06, 1.25, 2, right one, 5, 17. Okay, so 1.06, 1, just a little bit over, down 2. 1.25, negative 1. 2, 0, 5, 1, 17, 2. So way off the graph, it's going to 2. So something like that. Something like that. That's what your log looks like. And then don't forget your asymptote. This was moved right 1, so that is where my asymptote is, at 1. X equals 1, 2, 0. Domain, we're starting on the left, working right to the right. First thing to get to is my asymptote at 1 to infinity. Range, head it down forever, right forever. As this graph goes up, my x values are getting closer and closer to, they're going to just constantly keep going up. Because here is, as my graph went up this way for y values, my x values just keep getting bigger. As my graph goes down, going the other way, my x values are getting closer and closer to my asymptote. Guys, you also have a graphing calculator if you can't get these numbers. I am going to ask for 5 points in the charts on your test, though. So this is the best way I can teach you to do 5 points on a chart. But remember, you can always graph it. Log base 4 of x minus 1. But when you look at your table, you're only going to get, you can get like 1, 2, 3, 4, 5. So you can get those 5 points to graph. Or you can scroll and get nice points, 17, 2, but that's off the graph. 9, 1.5, 5, 1. So you don't have to get the same 5 points I have. You can just use your graphing calculator. But there you go. I'm going to leave you to do down 2, and I'll do one of these. This one has a fraction, so I'll do 5. So our parent function is log 1/2 to the x. So that means the inverse of log 1/2 to the x is 1/2 x. So my inverse of my parent function is 1/2 x. 1/2 raised to x. -2, -1, 0, 1, and 2. -2, well, let's start with 2. 2 is 1/2, 1/4, 1/2, 1, 2, 4. And you can put in the calculator, 1/2 to the -2. Make sure it doesn't do that. Or it won't always be the same, but okay, so that's your inverse. So then log 1/2, log base 1/2 of x, you flip them. So -2, -1, 0, 1, and 2. And then we have to do the transformations. So our translations, inside moves it left or right. Positive is to the left. Outside, up and down. Positive is up. So I'm going left 9 and down 4. Oh my gosh. Left 9 and up 4. Struggle. So my actual points I'm graphing. Did I flip them? Yeah, I flipped them. Okay. So I'm going left 9. I was at 4. If I'm at 4 and I go left 9, now I'm at -5. 2 minus 9 is -7. 1 minus 9 is negative 8. 0.5 minus 9 is negative 8.5. 0.25 minus 9 is negative 8.75. That's decimal. So that's left 9 and then up 4. So I'm adding 4 to all these. So negative 2 plus 4. That's what I did all the way down. So 2, 3, 4, 5, and 6. You know your asymptote is left or right, so you know left 9, so negative 9. Way over here. It's by 10, so I'm not going to waste your time. There we go. And then we have negative 5, 2. Negative 7, 3. Negative 8, 4. Negative 8.5, 5. 8.5. 5, 6. It's going this way. I need my x-intercept. So I need to know, when does this equation equal 0? Maybe an easy way would be to graph it. I don't know yet. I haven't graphing it. Log base 1/2 of plus 9 outside plus 4 is. And then you can go T. I'm going to know equals 0. So there it is. 7, 0. 7, 0. I think I counted that right. Since I already have a graph, I'm going to figure out my y-intercept as well. 0.8. And then I kind of know what everything else is doing. That was bad. There we go. Something like that. Okay. Domain. First thing I get to is my asymptote at negative 9. Not included. You can't touch your asymptote to infinity. Range. Negative infinity to positive infinity. Hi. And then hold on 1 second. And then the graph, as the graph goes up, my y values go up. My x values are getting closer to my asymptote, so it's getting closer to negative 9. As my y values go down, my numbers just keep decreasing, so they go down too, to negative 50. Okay, that leaves you 2 to practice on your own, and there's going to be more to practice on the review tomorrow. And your test isn't on Monday, it's on Tuesday or Wednesday, just so you know. So we'll have at least one day together to go over all this. All right. Email me if you have questions or join Google Meet.